All right, like I said, page 471, we're looking at example 3, and we're still working with similar polygons. All right, in this diagram, we're finding the value of x. We're told that ABCD, no, I'm sorry, ACDF is similar to VWYZ. My bad. ACDF is similar to VWYZ. And we got to find x. So we've got this going on. ACDF. 12x9. All right, we got to find the value of x first of all. So x represents side DF. And the first thing we want to do is we want to look at these shapes, and then we want to look at these similarity statements, because we're going to write a proportion. All right. So we need to align one of these two sides up top, AF and CD. We need to find out which one of those sides corresponds to this 6. Because when we're solving for x, we don't want anything corresponding to this 3y minus 1. So YW, Y and W, these two middle letters in here, correspond to CD. All right? So C to D is 9. So we're going top shape that's got a 9 for CD. If C to D corresponds to W to Y, we're going to put the 9 over a 6. Okay? We're going to set that equal to, we're going to take the x from the top, FD, we're going to put it in the numerator, and we're going to put it over whatever side FD corresponds to. Well, FD, or DF, is the third and fourth letter in the description, and it corresponds to the third and the fourth letter in the description, which is YZ. And Y to Z is equal to 10. Okay? Make sure your numerator, if your first numerator has the top shape dimension in it, and the denominator has the bottom shape, then top over bottom equals top over bottom. And then before you go any further, just make sure that your letters all correspond. The letters, the vertices that you got the measurements from. All right, so now we've got our proportion and we can solve for x. So we're going to take 6 times x, which is 6x, and we're going to set it equal to 9 times 10, which is 90. We're going to divide both sides by 6, and our x is equal to 90 divided by 6, 15. Everybody see it? We used the similarity statement to determine which sides correspond, wrote a proportion, and then we solved our proportion. So then the second part asks you to find y. So we're going to use the same concept. We're going to use the same mentality. Okay? We know that this x is 15 now, so we can maybe scratch it out and just put a 15 there in case we want to use that side. So this z to v corresponds to, here's v and z, first and last, corresponds to AF. Okay? And A to F is 12, so we can take 12 over ZV, which is 3y minus 1, set it equal to, we're going to set it equal to two sides that both have measures. All right? We don't want to use side AC and side VW. They don't have a measure. So we can pick any two other sides. And we can use this same pair here. All right, we know that the 9 6 corresponds. The 9 over the 6, they correspond to each other. So we'll set it equal to 9 over 6. Everybody okay with that? All right, again, we went top shape over bottom shape equals top shape over bottom shape. From our similarity statement, we know which sides correspond. So now we're going to crisscross multiply. And we got to do the distributive property here with this 9 times 3y minus 1. All right, it's equal to the 12 times 6. And 12 times 6 is 72. So go ahead and finish that math if you want to. I'm going to scroll down and then I'll finish it. So we got our 9 times 3, which is 27, y, minus 9 times 1, which is 9. It's equal to 72. Add 9 to each side. And our 27y is equal to 81. And divide both sides by 27. So our y is equal to, I'm guessing 3. Our y is equal to 3. All right. Questions? All right, let's look at the guided practice down there in the bottom of example 3. We're going to do that now as well. Same type of problem, except it's triangles. And our similarity statement is that triangle JLM is similar to QST. Here's our two triangles. All right, so we have to solve for x first, and then we have to solve for y. So I'm looking at this, this 6x minus 3. And that is side LM. And side LM is right here. So LM corresponds to ST. So now I'm going to go left shape over right shape in my proportion. I'm going to go left over right. So I'm using 6x minus 3 over ST, and S to T is 3. And it's equal to, I'm going to use this 4, right? We don't want to use the 3y minus 2. We don't want it in this proportion. So I'm going to use the 4, which is JM. J to M. J to M's first and last. J to M corresponds to QT. And Q to T is 2. So again, we can crisscross multiply. We've got 6x minus 3 times 2. That's equal to 3 times 4, which is 12. We're going to distribute. So 12x minus 6 equals 12. We are going to add 6 to each side. So our 12x equals 18, and then we're going to divide by 12. So our x equals 18 divided by 12 is 1.5. And then we're going to solve for y. All right, so when we solve for y, we're going to use this 3y minus 2. I'm going to use it in the numerator. So 3y minus 2. That is side JL. Side JL is right here, first and second letter in the description. It corresponds to the first and second letter in the description, which is QS. And Q to S is 5. So our 3y minus 2 goes over the 5. We're going left shape over right shape. We're going to set it equal to. Now, this makes the second problem easier if you're still using the same two shapes. This 4 over 2 was a legitimate ratio. It's still a usable ratio. You've got two numbers in there and you're solving for a variable, so use the 4 over 2 again. So again, we got 2 times 3y minus 2, and it's equal to 5 times 4, which is 20. Our 2 times 3y is 6y, and our 2 times negative 2 is negative 4, equal to 20. Add 4 to each side. Our 6y equals 24, and then divide both sides by 6. And our y is equal to 4. So there's our y, and there's our x. Everybody okay with that? All right, again, we're using the similarity statement to determine corresponding sides so that we can write a proportion. We use the proportion to solve for whichever variable they're asking us to solve for. All right, so look at the bottom of page 471. And this is a really important rule that you need to get into your notes. Theorem 7.1, perimeters of similar polygons. And it states that if two polygons are similar, then their perimeters are proportional to the scale factor between them. What they're saying here is you can use the scale factor to determine perimeters of two polygons. So turn the page and look at example 4 on the top of page 472. All right, so here's what's going on. They're telling you that ABCDE is similar to PQRST. Find the scale factor and the perimeter. All right, so here's our first shape. It's a pentagon. ABCDE. We got one side that's 5. This side is 4. And E to D is 6. And we've got tick marks. So we're going to use the tick marks to determine side BC, which is also 5, and side AE, which is also 4. So all of that information is given. Everything's given. We haven't done any math yet. We haven't done any geometry. We've got another pentagon that's smaller. PQRST. We're told that RS is equal to 3. And if RS is equal to 3, P to T also has 3 tick marks, so it's equal to 3. All right, so the rule that we just wrote down was that the perimeters are equal to the scale factor, right? So we can find the perimeter of the shape on the left. We know all the sizes. And we've got corresponding sides, so we can find the scale factor. So let's find out what these 3's, since we only have one dimension in the shape on the right, let's find out what they correspond to. And we've got RS right here. RS is equal to 3. And here's RS. Third and fourth letter in the description. RS corresponds to CD. All right. And C to D is 4. So our scale factor, remember our scale factor is the ratio of corresponding sides. Since ABCDE is listed first, then that dimension goes in the numerator. So CD is 4. Our scale factor is equal to 4 over R to S is equal to 3. So all we do is find two corresponding sides with dimensions, and we write them as a fraction, and that's our scale factor. If it's not in simplest form, you want to simplify it, get it into simplest form. So look, our scale factor, shape on the left over shape on the right, is equal to perimeter of the shape on the left over perimeter of the shape on the right. So our perimeter of this shape is equal to, we got 5 and 5 is 10, and 4 is 14, and 6 is 20, and 4 is 24. $10, 24, right? So look, scale factors 4 over 3 equals perimeter of the shape on the left, which is 24 over perimeter of the shape on the right. So again, we're just going to crisscross multiply. We're going to take 4 times p, which is 4p, set it equal to 24 times 3, which is 72. Divide each side by 4. And our p is equal to 18. So we use the perimeter of the shape on the left and the scale factor to find the perimeter of the shape on the right. Everybody okay with that? All right, so let me give you a little bit of practice to do today. And it's going to be on page 473. Five and 6. $20.21. $23 and 24. All right, again, make sure that you're checking the odd problems in the back of the book as you're doing these, and make sure that you're checking focus for electronic assignments after you complete these assignments.